Good day everyone! Welcome to Grade 10 Science second quarter. This time, we're going to have an introduction to the mirror equation. Last meeting, we already have a discussion about the ray diagram, but this time, we're going to prove if the ray diagram really reflects on our mirror equation topic for today. Mirror equation expresses a quantitative relationship between the object's distance and the image distance and the focal length. Here, we have our formula. So mirror equation is 1 over f is equal to 1 over dO plus 1 over di. dO stands for the object's distance, while di stands for the image distance. We also have an important discussion and we will use prior to our application. Magnification equation relates the ratio of the image distance and the object's distance to the ratio of the image height and the object height. It gave us an equation of m is equal to hi over ho, which is equal to the negative value of image distance over object's distance. And importantly, we have our sign convention. If the focal point of a given problem resulted to positive, that gave us a concave mirror. But if the focal point of the image or in the problem gave us is negative, then that is a convex mirror. Likewise, if the distance of the image is positive, thereafter it's a real image. But if it's negative, that is a virtual image. If the magnification of the image is positive, the image resulted is an upright image in orientation. And if it's negative, the magnification of the image is considered to be an inverted image. Let's work with our sample problem. A 4.00 cm tall light bulb is placed a distance of 45 cm or 45.7 cm from a concave mirror, having a focal length of 15.2 cm. Determine the image distance and the image height. So let's solve our problem in a very systematic manner. So let's start with our own given. So for our problem, the given in our problem, let's write our given. We have 4.00 cm tall light bulb. That is 4.00 cm tall light bulb and 45.7 cm. 45.7 cm and the focal length of 15.2 cm. So 15.2 cm is our focal length and 45.7 is placed a distance. We also have a 4.0 cm tall light bulb. It is the image height or height of the image is placed a distance of 45.7 cm, a distance of an object, or we also have the DO. This is a 4.0 tall light bulb. It's an object's height. Sorry for this one. This is an object's height or height of the object, and we also have the distance of the object. Okay, now we have our unknown. So what we are looking for in our problem. So for our unknown, we are asked to find out or determine the distance of the image and the height of the image. So we are looking for the DI and also the height of the image or HI. And let's start with identifying the formula na gagamitin natin. In order for us to arrive with a particular formula, we all know that we need to substitute the given mirror equation in order for us to understand it, particularly then plug in the given values in our problem. So 1 over f is equal to 1 over dO plus 1 over di. So this is our mirror equation. And to give us a very reasonable way on how to solve a problem, we need to substitute the given values. So 1 over f or 1 over f is equals to 1 over 15.2 centimeter is equal to 1 over DO, which is 45.7 centimeter, which is plus 1 over DI. Am I correct with that? Yes. So we're looking for the value of DI. This is what we are looking for. Then if we try to look with that, plug in our values, I will write it on the lower part. So 1 over 15.2. I will change my pen color. So 1 over 15.2 centimeter is equal to 1 over 45.7 centimeter plus 1 over DI. Okay, so use our calculator. Okay, so let's try. So in our calculator, 1 over 15.2 1 over 15.2 is equal to 0.658 or 0.0658 is equal to 1 over 45.7. 1 divide by 45.7, and this is 0.02189. 0.02188, sorry, or 0. Round it up, 0.0219 plus 1 over DI. Now, to isolate the given value, all we need is, of course, we need to isolate the 0.0219 to the other side of the equation by subtracting it. So we need to subtract 0.0219, negative 0.0219 to make it cancel, and 1 over DI is equal to, okay, so subtract natin, 0.0658 subtracted to 0.0219, and the answer is 0.0439 over 1. So 1 is equal to, cross multiply, over 1 is equal to 0.0439 multiply to DI, dividing both sides of the equation by 0.0439 to cancel it out and to get the value of DI, because we are only looking for DI or image distance, not 1 over DI. Because if 1 over DI, that is equal to the inverse of image distance. But this time, we are looking for the value of image distance only. And to do that, we need to divide the equation. 1 divided by 0.0439. And the answer is 22.78. Centimeter. Sorry, I forgot the units. So this is our answer. There is a quicker way on how to derive or understand the formula in calculating it directly to the calculator, in order for us not to have a long method. And we all know that the formula to get the DI is that 1 over DI is equal to, so we subtract the 1 over F to 1 over DO. So this is our formula to get the value of DI. Now, in calculator, if we have 1 over DI is equal to 1 over F minus 1 over DO, in order for us to get the inverse value, directly putting the values into calculator is much easier compared to the longer method. And it looks like this one. So with our calculator, we need to put 1 over di is equal to 1 over f, and 1 over f is equal to 1 over 15.2 centimeter. Subtracted to 1 over do, which is 1 over 45.7 centimeter. We need to isolate the value and get cross out with the 1 as resulted to di. And to do that, we need to multiply the whole equation to negative 1. So in our calculator, so 1 over 15.2 subtracted to 1 over 45.7 that gave us shift or negative 1. Let's look for negative 1, x minus 1 in my calculator, and it gives me a value of 22.78, the same centimeters, sorry. And how we put or input the following number in our calculator. And di is positive. Thereafter, if the image distance is positive, looking our conversion sign, that's positive, that is a real image, right? So this forms a what we call real image. Now, on the other half, how can we calculate the magnification of the image? So let's try to find out. So the magnification of the image gave us a value whether the image is either an upright or inverted image. In order for us to find out, let's try to substitute. If di is 22.78, m is equal to hi over ho, which is equal to the negative value of image distance divided to the object's distance. So we have negative 22.78 centimeter over the distance of the object is equal to 45.7 centimeter. 45.7 centimeter, which is hi or height of the image is unknown. It's hi over ho, wherein our ho is 4.00 centimeter. Am I correct with that? Yes. First step is to cross multiply this one and this one. So 4.00 centimeter multiply to negative 22.78 centimeter is equal to hi multiply to 45.7 centimeter. In order for us to get the value of hi, we need to divide both sides of the equation by 45.7 centimeter. That is 45.7 centimeter. Cancel it out to get the value of hi, and inputting the value in our calculator gave us or resulted to, we have 4.00 centimeter multiplied to negative 22.78 divide by 45.7. This gave us a value of negative 1.99. And this is negative. Thereafter, if the magnification or height of the image or magnification of the image is negative, thereafter, it gave us a value that it is an inverted image. Right? And inverted, likewise, if the object's distance or if the object's height is 4.00 centimeter and negative 1.99 is the image height, thereafter, the image is diminished or smaller compared to the object. Okay? Is that clear with you? As part of the short recap, let's try to do the following. Thank you!